Hello friends, welcome to video lecture on fluid mechanics. In today's session, we will continue with the application of Bernoulli's equation to Pitot tube. So see the principle of this Pitot tube and a relation derived for this Pitot tube by using Bernoulli's equation. So it is the device used for measuring the velocity of flow at any point in pipe or channel. It is based on the principle that if the velocity of flow at a point becomes zero, the pressure there is increased due to the conversion of kinetic energy into pressure energy. In its simplest form, the Pitot tube consists of glass tube bent at right angles. Okay, in this way that's shown in the figure. So this Pitot tube in its simplest form bent at 90 degree. The lower end, which is bent through 90 degree, is directed in the upward or in upstream direction. In this way, the liquid rises up in the tube due to conversion of kinetic energy into pressure energy. The velocity is determined by measuring the rise of liquid in the tube. Consider the 2 points. Here is the first point, here is the second point. At the same level in a such a way that the point 2 is just as the inlet of the Pitot tube and the point 1 is far away from the tube. Let this P1, V1 are the intensity of the pressure and velocity of flow at point number 1, and P2, V2 are nothing but the pressure and velocity at point number 2. So here actually the velocity you can get as a 0. Okay, so this H indicate the depth of the tube in the liquid. H indicate the rise of the liquid in the tube above the free surface. Now applying the Bernoulli's equation at point number 1 and point number 2. So applying Bernoulli's equation at point 1 and 2, we get in this way: P1 divided by rho g plus V1 square divided by 2g plus Z1 equals to P2 divided by rho g plus V2 square divided by 2g plus Z2. Now here if you just see, the level is same, so we can just say here Z1 equals to Z2 as point number 1 and point number 2 are on the same line. So in this case the value for the V2 is also 0. Now this P1 by rho g is nothing but the pressure head at point number 1. So this indicates the pressure head at point number 1. At the same time, if you just see the pressure head at the point number 2 is nothing but H plus. Here this pressure at the point number 2 is nothing but this small h plus this one capital H. This way you can get that pressure head. Now substituting the these values into this relation. So see here, this P1 divided by rho g is nothing but H. This term will remain as it is. Z1 equals to Z2. Means this get cancelled. And what's about this this term? P2 divided by rho g is nothing but the small h plus capital H. In this way you can get the same term. As the value for V2 is 0, this term get cancelled. Okay, so this term will not come here. Now what's about the next one? So from this relation, you just here the capital H get cancelled. So here we can get the small h equals to V1 square divided by 2g, or V1 equals to square root of 2gh. This is theoretical velocity. Actual velocity is given by V1 actual is nothing but the CV into square root of 2gh. So this indicates CV is nothing but the coefficient of Pitot tube. So velocity at any point is nothing but C equals to CV into square root of 2gh. Now velocity of the flow in pipe by Pitot tube. For finding the velocity at any point in the in a pipe by Pitot tube, the following arrangements are adopted. So see, the first arrangement is here. The Pitot tube along with the vertical piezometer tube. So this arrangement is here. Then Pitot tube connected with the piezometer tube. And this is nothing but another arrangement. Then Pitot tube with the vertical piezometer pipe connected with the differential U tube manometer. Okay, so in this way. And next one is nothing but the Pitot static tube, which consists of two circular concentric tubes, one inside the other with some angular space in between. In this way, that next arrangement with us. Then you just see here some actually a space in between these two pipes. The flow is passing through this pipe. The outlet of these two tubes are connected to the differential manometer, where the difference of the pressure head H is measured by knowing the difference of the levels of the manometer liquid, say X. Then H is nothing but X into Sg divided by S naught minus 1. Now let us discuss about some of the numericals on the same topic. A Pitot static tube placed in the center of 300 mm pipeline has one orifice pointing upstream and other perpendicular to it. The mean velocity in the pipe is 0.8 of the central velocity. Find the discharge through the pipe if the pressure difference between the two orifices is 60 mm of water. Take the coefficient of Pitot tube as Cv equals to 0.98. Now see the diameter of the pipe D equals to 300 mm. Then difference of the pressure head, that is H, equals to 60 mm of the water. Okay, that convert it to a meter by multiplying 10 raised to here minus 3. You can get 0.06 meter of water. Then Cv is given 0.98. Then the mean velocity is nothing but is the product of central velocity and here 0.8 of the central velocity. This information is given. So 0.8 multiplied by central velocity. So central velocity is given by this relation Cv into square root of 2gh. So Cv with us 0.98, G with us 9.81 and H with us 0.06. Okay, so do the calculation, we can get 1.063 meter per second. So after this, get the value for the V in this way, 0.8 into central velocity we can get as 1.063. just substitute here and get the value for mean velocity. So mean velocity V is nothing but 0.8504 meter per second. So discharge we can get area of the pipe multiplied by velocity. So area of the pipe with us pi by 4 into d square multiplied by this V. Substitute the value of diameter, substitute the value for V here. So discharge we can get Q equals to 0.06 meter cube per second. And find the velocity of the flow of an oil through a pipe when the difference of mercury level in a differential U tube manometer connected to the two tappings of the Pitot tube is 100 mm. Take coefficient of Pitot tube 0.98 and the specific gravity of oil 0.8. So here the difference of mercury level with us X equals to 100 mm. Then the specific gravity of the oil with us 0.8. Then the specific gravity of the mercury with us 13.6. Cv is given 0.98. Okay. Then the difference of pressure head, that is H, is nothing but X into Sg divided by S naught minus 1. This relation with us. Now substitute the value for the X. X with us 0.1 meter. Okay. So Sg indicate the specific gravity of the mercury, that is 13.6. This indicate the specific gravity of the oil with us 0.8. Substitute here. So we can get H equals to 1.6 meter of oil. Then get the velocity of the flow, that is Cv into square root of 2gh. Substitute the value of Cv, G and H. So after doing calculation, you can get 5.49 meter per second. So our target is to calculate here velocity of the flow. Is completed here. So let us start with the next problem. A pitot tube is inserted in a pipe of 300 mm diameter. The static pressure in a pipe is 100 mm of mercury. The stagnation pressure at the center of the pipe recorded by the pitot tube is 0.981 Newton per centimeter square. Calculate the rate of flow of water through pipe if the mean velocity of flow is 0.85 times the central velocity. Take CV equals to 0.98. Given diameter of the pipe D equals to 300 mm. So that must be converted into meter by multiplying 10 raised to minus 3. So 0.3 meter. Then area pi by 4 into D square. So D with us 0.3. Substitute here and get the area. Okay. So area after doing calculation we get 0.07068 meter square. Static pressure head here given 100 mm of mercury. Okay, in this way information with us. So specific gravity of the mercury with us 13.6 multiplied by this one, we can get the 1.36 meter of water. This static pressure here must be a negative of that water. So stagnation pressure with us 0.981 Newton per centimeter square. In this way, just convert into Newton meter square by multiplying 10 raised to plus 4. Okay. Then a stagnation pressure head. This indicate the P divided by rho g. So this value with the substitute here. Substitute the value of rho g. We can get the 1 meter. Then H indicate the stagnation pressure head minus the static pressure head. So this value with us 1 minus this one minus 1.36. In the we can get 2.36 meter of water. So get the velocity at center CV into root of 2gh by using this relation. Substitute the value of CV, then g and h, we can get 6.668 meter per second. In the mean velocity we can get 0.85 multiplied by this velocity at center 6.668 multiplied by this 0.85, we can get 5.6678 meter per second. So rate of flow of water is nothing but here the area of the pipe multiplied by velocity. So velocity with us, area of the pipe is also with us. Already the area is calculated here. We substitute this area here and get the rate of flow of water, that is 0.4006 meter cube per second. Thank you. I hope that in the today's lecture concept of the pitot tube is discussed, that clear to you. Thank you.